Assalamualaikum everybody and my lecturer. I am Ahmad Mukhtar Syahimi from Mathematics 2. Want to present about application of vector in real life. So, before we dive deep into the application of vector, we need to know what is mean by vector. Vector is something that have both magnitude and direction. For example, the displacement for example the velocity of a car, which is we have like 25 kilometer per hour straight line. That is the example of vector, which is have a magnitude which is 25 kilometer per hour, and the direction straight line or to the north or to the south of the city. This is the example of vector. And example of non-vector is time, which is it have a magnitude like 12 p.m. but it doesn't have any direction. How do we illustrate a vector? A vector can illustrated by using line segment, which is have an arrow to represent the direction of a vector, and the length of the line segment represent the magnitude of a vector. We denote a vector using a boldface like A or B, but when we write using hand, we cannot use a boldface. How do we use boldface when we writing with hand? Am I right? Then we the mathematician use alphabet with an arrow above the alphabet to represent the vector of something that we want to write. For the sake of the knowledge, let us see the example of what I mean by boldface and the writing of the vector. This example show a vector which is A come from the two vector which is ax represent the graph. When we write a graph, we have a x intercept and y intercept, which is horizontal and vertical line. The vector can illustrate like that too. We use ax and ay in this example to represent the vector of A, which is combination of the magnitude and the direction, or we can say the A is combination of two vector also, which is vector ax and vector ay. So you can look at the example. Why do I write A equal to bracket ax and ay? That show the how you can write a vector in a correct way. There are many type of writing a vector, but some of them are like that. And the magnitude of a vector we can write by add some tiang at the alphabet, and the formula is same formula to the distant formula, which is x square plus y square square root x square and y square. So this is a some formula of a vector that we can use, which is we have a formula for find the magnitude, as I already say. formula when adding or subtracting a vector, which is something really easy. You can add a vector like adding a simple number, but you have some rule. And on the example, on the application, next I will explain how to add and subtract the vector. And other than that is multiplication of vector, which is when we want to multiply two vector. We have a cross product and dot product. Cross product when we multiply two vector and you have magnitude and direction, and dot product when we multiply two vector in it resulting only magnitude of a two vector. Is about the formula when we have a example. As you can see, the black box, the black diagram show the vector in a graph represent x and y, and we have a vector a. To find the coordinate of x and y, we use a formula from polar coordination to Cartesian coordination. And when we have a Cartesian coordination, we need when we need to find a polar coordination, we use the right hand side formula to find the direction and the magnitude of a vector. So you can look at some example, and we use this formula to calculate an example that I will explain more. So we can deep dive into the application of a vector, which we have many application of a vector, but in this slide I will tell you about application of vector in navigation. So navigation refers to the process of monitoring and controlling the movement of a craft or vehicle from one place to another that involve location and navigation position relative to non-location or pattern. The uses of vector are crucial in this field because it determines the course, position and distance traveled to guide the movement of a craft or vehicle from one place to another. The slide say like that, which is I can explain it to you. When we drive a car or craft, we need to know the direction and the movement of our car or craft or airplane, which is we need to use a vector when we want to find the direction of a magnitude, which is in this example the speed of a car or airplane. The term of navigation used in various fields such as land navigation, marine navigation, aeronautic navigation and space navigation. The term bearing often used in navigation that show the angle from north, for example south, east. To get more understanding about vector, we can look the question. Example of the question that given, which is an aeroplane is flying in the direction 50 degree north of east at 550 miles per hour. A wind is blowing in the direction of 15 degree south of east at 45 miles per hour. What is the actual speed and direction of a plane?
What is mean by actual speed?
Actual speed is speed of an aeroplane when combined with wind. So we can look at the diagram that I have given. to illustrate, to imagine what was happened in this question. The diagram that we have made clearly diagrammed the direction of aeroplane and direction of wing. We only need to find the vector that added from these two vector, which is the direction of aeroplane and direction of wing blowing to the aircraft lah. So before that, we need to find the vector of aeroplane and the wing by using the formula that I have already started before, which is we can assume that A is for the vector of aeroplane and B for the vector of wing to make us easier to write down. So we use the formula. You can see as I write A, which is we have the formula and we only substitute the magnitude and the direction into the formula, and we got the direction and the vector of aeroplane and the vector of a wing blowing to the aeroplane. To find the actual speed, we need to find the magnitude of the vector, which is, like I say, we need to multiply or plus the two of this vector, which is the aeroplane and the wing. We multiply the two of the vector and we got the answer, which is 57473 and 13065. We find the magnitude by using the formula of the distance, which is the formula I already told before in the third slide, and we got the magnitude of the vector, which means the speed in this example, the speed of the aeroplane plus the wing is 489.4 miles per hour. This is the actual speed of the aeroplane that fly with the resistance of the wind blow toward the aeroplane. After that, the question asks for the direction of the aeroplane, and as I already mentioned before, we can use the formula for direction, which is theta equal to inverse tan vector A per vector B, and we only substitute the vector in this formula to find the direction of airplane. So why we use this formula, which is formula from the Cartesian coordination to the polar coordination? So in that diagram, which is we have aeroplane and wing, that is a Cartesian equation coordination, and we need to form a polar coordination to find the direction and the speed and the magnitude of the aeroplane, and we use this formula to find that direction and magnitude of the vector, which is we find the direction of the aeroplane is 12.8 degree to the from north of east. In conclusion, in navigation, vector are essential too for representing and calculating speed and with direction. They help airplane alter their way by pointing out the direction and speed of airplane, which is essential for effectively arrive at a certain location. That's all from me. Thank you.